Our group describes the topic thinking for speaking, how brain operates in these processes, especially in deaf children, grounding on the research carried out by Van Slovin, an outstanding professor of psychology and linguistics at the University of California, Berkeley. This investigator executed a research on the acquisitional and developmental skills of deaf children living with hearing parents and deaf children living with deaf parents. Before moving on to the main topic, first we explain briefly how brain works on normal people's thinking and speech production. Thought, speech, and activity are not separated. Man regularly perceives an action in his mind before undertaking an activity. So, at this time, I report how brain works in the thinking process. The brain primary building element starts with brain cells known as neurons that determine mental process along with thinking. Cells called glia exist between the neurons in the brain. According to Mark Treadwell, an educator from New Zealand, the glia interact with the neurons and the hormones chemically in the production of thought. The motor neurons produce the action in our muscles, and the sensory neurons connect to the five senses. Now I'm going to explain how brain works in speech production. The center for speech production is the left hemisphere of the brain. And the parts of the brain that control speech production are the following ones. Broca's area, which is in charge of producing speech sounds. Wernicke's area, which implies the understanding of speech. Motor cortex, that controls the movements of muscles, including those of the face, jaw, tongue, and larynx. Articulate fasciculus, that connects Wernicke's area to Broca's area. Now, I explain how the brain works in the speech production. First, information gets to the primary auditory cortex. Second, from the primary auditory cortex, information is transported to the posterior speech area, that is the Wernicke's area. Here, in the Wernicke's area, words and phrases are arranged, transforming into meaningful speech. After that, from Wernicke's area, information travels to Broca's area through articulate fasciculus. And finally, this information goes to the primary motor cortex.
Deaf and only learn sign language will, not surprisingly, think in sign language. What is surprising is those who were born completely deaf, but in terms of mental capacity or the like, rather it is because of how integral language is to how our brain functions. To be clear, language here not only refers to spoken languages, but also to sign language. It is simply important that the brain has some form of complex language it can fully comprehend and turn into an inner voice in order to drive thought. More specifically, language is integral in such brain functions as memory, abstract thinking, and, fascinatingly, self-awareness.
Spoken and sign language are laid in the same areas. But a difference of normal people who hear, deaf people has a little bit different process of language production in their brain. It is because in the temporal lobe the hearing functions are not working, because they can't receive any auditory stimuli. Therefore, the input that deaf people get is mainly visual. Then the language processing in deaf people begins in the occipital lobe, where images, colors, and forms are processed. After this information is decoded in the Wernicke's area. In this area, the process of thinking is produced in order to understand what the another person is communicating and recognize the message. Then the brain identifies the correct sequences in signal language and get the meaning of every sign so the answer can be produced. Another area that is involved in is the anterior part of the broadcast area, where the information is changed into semantics. Instead there is no speaking, they try to get a real meaning of each sign to communicate fluently. Moreover, we have to remember that they can also produce writing language. So they need to understand the meaning and forms of each letter to be used in words and in sentences. Another important part that is involved in this process is the primary motor cortex, that is located in the posterior part of the frontal lobe, and it is in the charge of the body voluntary movements, especially hands action, that are mainly used in the production of signal language.
So what are the pedagogical implications of thinking or speaking? We as teachers have to be aware of the following aspects. When we learn the mother tongue, Spanish in our cases, we don't need to use complex thinking processes inside our brains, because this is our first language. So we don't think too much. On the other hand, learning a foreign language like English involves a higher thinking process in our brains. This is because we have to understand also grammatical paths in order to produce speech. For this, gestures also play an important role in learning a language. For example, as we have seen before, for deaf people, gestures and signs are very important for their communication. So we can take advantage of these aids also. Now, we have to think of some good strategies as teachers to get our students to speak and overcome speaking anxiety. For example, one of these strategies is miming. We can mime actions and encourage our students using flashcards to describe vocabulary. But don't forget also to teach grammar explicitly. This is very important to form the paths. Explorers is another good technique that we can use in our classes, because here the students are asked to go out and describe something they have seen to the whole class. Doing and explaining can also help students improve their speech. By explaining what they are working on, the students can overcome oral problems. Finally, a very important strategy for overcoming speaking anxiety is the constant practice of self-reflection that can be done, for example, by recording ourselves, how we speak, how we present something, and then reflect on the strengths and weaknesses that we have found. This is all that we have got, and thank you for watching our video.